My name is Gordon Lohmeyer. I'm with the Texas A&M Engineering Extension Service, and today we're proud to have Chris Green with us. Chris recently retired from the Seattle Fire Department, where he served as a captain, and more importantly, I think his knowledge and background in all things energy. You know, Chris, when we talked a couple of months ago, we were talking about solar farm technology, thin cell solar panels, and really the increase in the solar footprint in just Texas alone. So, Texas currently leads the nation in wind production. So produce a lot of power via wind. And Texas is currently sitting at third in the U.S. for residential solar power generation. But I think that's going to change. We think that's going to change. We're seeing a big push for some very, very large solar farm installations. Just a couple of years ago, the Gemini project was the largest solar installation that we had in Texas. That Gemini project produces some 690 megawatts of power. That's a lot of power. But we have a new project that came online. It is known as the Samson Solar Energy Center. So that facility alone produces 1,310 megawatts of energy. So that's enough solar collection to power over 300,000 residential homes. So a lot of stuff that's going on in Texas right now with solar, our solar footprint. 10 years ago, over 80% of our power generation was produced by fossil fuels, primarily gas-fired turbines and coal plants. That produced over 80% of the power that we had in the grid. Now it's down to 61%. And kind of what's made that change is wind and solar. And, solar is the topic of the day. So, Chris, what do you think? With the new growth, of course, comes new hazards. We're introducing some new technology to our first responders, some non-traditional hazards. So where do you see this hazard falling?
One thing that's happened with this energy source is that traditionally it was made of silica. You'd have either a mono or a polycrystalline silica material is what these cells would be made from. But with advancements, they add additional minerals, they do chemical enhanced photovoltaic cells and arrays. And that's where the question starts to come in. If they used to just be sand or silica, which we felt like was relatively innocuous from a chemical hazard standpoint, how are the new ones falling into that? And unfortunately, there's a real innovative blind spot for what sort of problems come with chemical and mineral enhanced cells. And so what leads the forefront of that is what you just termed the thin film photovoltaic cell. Now, what we know right now is that 20 years ago, thin film cells globally occupied less than 1% of the total photovoltaic space. Today, they occupy 10% globally. Here in the US, on the infrastructure level side of photovoltaic energy creation, which is 80% of all of the photovoltaics in the country fall into that 50 megawatt or greater systems. Most of your systems are residential rooftop, but they don't make very much energy when compared to infrastructure level solar farms, ground mounted, huge fields. That's where 80% of the energy is actually made. Well, in that space, we know that 25% of those materials fall into the thin film cell material. Now, if we look at that even closer, we find that most thin film cells are made from what's called cadmium telluride. And therein lies the question. Cadmium is one of the 5 heavy metals, that we're aware of, that concerns us. They're very toxic to the environment, and we don't really know what happens when they burn, when they fail. How does it affect our fire crews? How does it affect the ground where they fail? These are questions that are largely unanswered. We don't want to fearmonger and we don't want to overreact, but at 25% of the infrastructure level producing solar farms in the US, if those fall into the thin film cell area, with most of those being cadmium telluride, I think that number is a little too great to ignore anymore. At 1% globally, we might be able to look the other way and not feel the pressure to ask those questions. But at 25% of our 80% highest level production here in the US, I think that this may be a problem. Sydney's Aquatics Center in Australia, a huge fire, 1.3 megawatt system, rooftop system. Now remember that the expectations of safety around photovoltaics in Sydney are very different from the US. Like, they're not required to have rapid shutdown. There's a lot of safety features that we have here that are code required that are not present in Australia. But here's the other thing that we know. Those cells on that rooftop of the Aquatic Center, they were thin film. There's over an 80% chance that those thin film cells were cadmium telluride. Now, one of the reasons the industry is going down that thin film lane is because they can be made faster. They can be made less expensive than traditional silica and mono and polysilica. And the efficiencies are higher than polycrystalline and just slightly lower than monocrystalline. And so when you look at rate of return on your investment, this looks like a good thing for your business model. They're cheaper, you get your investment back a little bit faster. Now, we know that they don't last quite as long as a mono or polycrystalline cell, which can last as many as 25 years. But poly is lasting more than 15 years. And the reality is, if you're running a business and you're just looking at the next couple of quarters, well, it's a lot easier to justify thin film investment than monocrystalline, which would be the most expensive type to put out there. The two most common thin films out there, with more than 80% of them of thin film being cadmium telluride, the next most common is what's called copper indium gallium selenide. Again, more burn questions about what happens to those chemicals, what happens to that stuff when it burns and fails. Does it get into our gear? Can we launder it out? What happens with the soil? These are just unanswered questions that we need to address. In a large solar farm, a large solar field out in the middle of nowhere in Texas, that fire is likely to come in as a grass fire. Now, if the responding crews are a wildland team, they may not even be outfitted with a mask. And if we look at solar, at photovoltaics as being just glass, silica, basically an innocuous hazard, that may be short-sighted, especially when it comes to infrastructure level ground-mounted systems. And those are some of the questions I think that we need to start asking upon installation and pre-fires would be, what is the material? What types of cells are you using? And that can be one of the fastest ways to know what you're dealing when you're rolling in. So that's some of the things that kind of concern me, that we'd like answers to for the crews that are going to have to actually face down these hazards, because they're not what they used to be. Not all cells are created the same.
Sure. This is a parallel to the testing that we did or conducted 3 weeks ago at Southwest Research Institute, where we forced lithium-ion batteries in the thermal runaway. And the point wasn't, could we force these batteries in the thermal runaway, because we knew we could. Once you get a little extra power in those batteries and you start to see that heat increase, they're gone. They're going to take off and they're going to propagate a bad situation. It's kind of the same parallel with solar farm technology. You think kind of an innocuous type of setting, these ground-mounted panels, but if you really look at the chemistry or how these panels are constructed, we don't fully understand when they burn what the potential effects are, health effects to the first responder community. And that's concerning. I was thinking along those same lines, that seems like the greatest hazard to me is that wildland urban interface, or that wildland solar farm interface. That's kind of a likely scenario. If you look at the Smokehouse Creek fire that happened a couple of months ago in the Texas Panhandle, we're talking over 1 million acres of impacted Texas property, and that's a reality. So the crews, the wildland crews that have wildland gear, little, possibly no respiratory protection, could have some potential exposure, or exposure to fire departments that really don't have a full grasp or understanding of what the potential hazards are in the solar farm. So, if you enter the solar farm, what's really visible are these ground-mounted solar panels. That's the thing that we see. I'm thinking about a solar farm that we have just east of us. There's 535,000 solar panel arrays connected to an energy storage system, but there's a little bit more equipment between the solar panels, and the transmission lines where the power will live post collection. You have the solar panels. There's an inverter, that's gonna turn that DC power into AC power, because it's AC power. That alternating current is what us, the consumer, uses. There's going to be some type of a transformer or a substation, inside of a switch yard, and then potentially some battery storage. A lot of these solar panels that I've seen, they have some type of energy storage system or battery system, as you will. So there's a lot of potential exposure, and I don't want to be a downer either, but it's something that we have to fully grasp and comprehend when we respond to an energy storage system or a solar farm, that there are more potential hazards that are involved, because these cells, these solar panels, they're always on. You don't have to have direct sunlight for these things to be receiving a signal. If there's light in the environment, they're trying to collect that light and generate DC current. There's this term out here, the solar heat island effect. I don't know, Chris, if you've heard that term used, the solar heat island effect. I was able to go out into a solar farm at about 10 o'clock at night. So I wanted to feel if there was a heat effect, and it is. It felt measurably warmer. I would say probably 8 to 10 degrees warmer in the farm than outside of the farm during nighttime, normal conditions. Just more things to be aware of. You've got the panels, you've got the inverter, changing that DC current to AC current, the transformer, the substation, a switch yard, and then some battery storage capabilities that will be all collected, within that solar farm. So some potential hazards that we need to be aware of. Chris, one of the things that I've seen that's being marketed is, I call it latex in a can for lack of a better term, but it's a pressurized fire extinguisher that contains a latex material that can be removed from the solar panel to basically block the light transmission. So the solar panel isn't sitting there trying to feed energy to the energy storage system during fire conditions. Have you seen kind of first responder technology to help us out with this?
I have. There was a fire a little less than a month ago over in Illinois, and it was a rooftop system fire, relatively large system. They put it out with dry cam and a hose line, and then they used this PV stop material, which is basically that black matting goop that comes out of a 2.5 gallon pump can. They're about $500 or $600 a can, and you spray it on the cells. Now, you don't spray it on them while they're burning. You're putting it on them the same way you would with just black 6 mil plastic, where you're just trying to cover the cells so they're not getting any more sunlight and in effect de-energizing them. It does seem to be effective on a small scale. How deployable it would be on a large scale system, I'm not really sure. We'd have to see that tested. But yeah, in Illinois, they were happy with what they got out of it. I was able to work with the crews that deployed it. They were happy with it, deployed pretty easily. But make no mistake, the fire was put out with dry chem and hose lines. So that's what put that fire out. And it was started by the array system, and it started cooking off the flat membrane roof is what ended up burning. So they were lucky in that the fire came in midday, because if it had come in at night, they might have been delayed in their response to that. 30 years ago, when we saw solar panels on a rooftop, we were not thinking a battery backup system. Today, you have to, and certainly in a photovoltaic farm, a field, a large farm, with ground mounted systems, they can have voltages as high as 1500 volts DC. So the shock hazard is a little bit higher, and the battery component will be with it, because like most of like wind and solar energy, it can make the energy, but it has no capacitance. So that's what's interesting about a large solar farm. It has no electrical capacity to it, right? Meaning when the sun goes down and it's covered, it's not making any more electrical energy, but it certainly has a thermal capacity to it, which is something you experienced at 10 o'clock at night. They do heat up, they do hold heat for a little while. The days of the US Fire Service being able to just get by with not giving photovoltaics its due are probably over. They are intimately connected to the grid now. They're connected to batteries. The voltages are different from residential to commercial to ground mounted systems. They can be different. There's rapid shutdown features now that are going to be present with rooftop systems that most crews don't really understand. De-energizing and isolating these systems are two very different things. The photovoltaic space needs to be revisited by the fire service. And frankly, we've just gone headlong into batteries, which is not necessarily a bad thing. But as I like to say, don't miss the energy battleship, focusing too hard on batteries, because solar is part of that battleship, as is your transmission lines and your substations, switch gears and manholes, and everything else that makes up the energy spectrum. Batteries are just a piece of it, but there's an intimate nexus between that entire wheel. And that's really the space that I think the fire service needs to do a better job of building out. Well, I sure would hate to see photovoltaics go the same way that batteries did, where we just backburner it, we assume we've got it handled when we really don't. And now there's an innovative, a big change happening with solar. And whether or not thin film will grab hold or not, I don't really know. But at 25% of the ground mounted infrastructure level support for our energy, I don't think we can ignore that anymore. We need to approach really our academic trusted sources like TEEX, like UL, FSRI. We need them to take a close look at these thin film cells, burn them, break them, do the gas testing, find out what happens to them when they fail, because that isn't required to get these things on the market. That sort of testing is not required out there. And that's kind of one of the gaps that, again, at 1% of the market, fine, we could look the other way. We don't really have to worry about these because they're truly an anomaly. But in the ground mounted infrastructure cell space, they're not an anomaly. They're 25% of it. And there's an 80% chance that those thin films are going to be cadmium telluride. I'm a big fan of solar. I think that it is part of the future. I'm a little concerned that it still takes anywhere from 4 to 7 acres to make a megawatt of energy. Because when you talk about 40,000 megawatts being built out in Texas between now and 2026, which is number one in the nation, as far as projected build out, it's the highest in the nation. I think about 40,000 megawatts and how much land it takes to make 1 megawatt. When you look online for what it takes, depending on where those cells are located, it can be anywhere from 4 to 7 acres. And they're often supporting that system. They're supplementing it with wind turbine. But that's a lot of land. A lot of people say, why can't we just move to nuclear? Well, that's the problem. We don't have a really good solution to the waste. And what I would ask is, do we have a good solution to the batteries? Do we have a good solution for the solar? And we may, again, I'm not a fear monger. I just think that we should be asking these questions. And sometimes it takes the fire service, people who are intimately involved in these things when they fail, and that is the U.S. Fire Service. It takes that group asking the questions and demanding answers.
Absolutely. You know, we kind of started the conversation with Texas. You know, we're number one in wind, number 3 in solar. You know, right now we're at 23 gigawatts in the state of solar energy. In the next 10 years, we're expected to surpass 100 gigawatts of energy produced from solar, which it's great. When you look at our infrastructure that's controlled by ERCOT, man, wind and solar really saved us last summer, because it helped us to sustain, you know, above 3,000 megawatts residual power in the grid. So we didn't have the rolling brownouts that we experienced before. That's fantastic, because we have more people that are moving to the state. We have higher energy demands, and we have to get that power from somewhere.
You're absolutely right. Our energy demands are not going down. They're only going up. And the reality is, a modern infrastructure grid for the US will not work without wind, solar, and batteries. And they may not be lithium ion batteries, they may be vanadium flow. There's all kinds of different battery technology. Sodium ion is having a big
Yes.
impact right now. The system requires this evolution. But again, with the evolution comes blind spots, and it's the fire service that time and time again is revealing these blind spots. And we're just asking for more information. We're just asking for this stuff to be looked at more critically under duress when it fails and how it does affect our U.S. firefighting force.
If you see a collector, whether it's a wind turbine out in the field or offshore or a solar farm, it's a collector. It's collecting energy. It's transferring the energy. The energy is being converted from DC to AC. It goes to a substation, to a battery storage facility, and then back into the grid. So there's a front end, and then there's a downstream end user component. But that piece in the middle, that's the piece that's concerning. In the fire service, when we don't have all the answers and we don't have all the facts, so we're dealing with potentially, at this point in time, some unknown hazards that could be produced through the fire phase. So we're going to gear up. We're going to do the right thing. We're going to keep our gear clean. Always have to keep that gear clean. That's really, really important. And I anticipate here within the next 2 months, we'll have our report back that'll show the products, the VOCs, the polycyclic aromatic hydrocarbons, these nanoparticle heavy metals that are part of these battery packs. What does that mean? What does that mean from a chemical exposure perspective? What does that mean post NFPA 1851 water-based cleaning? And what does that mean after liquid CO2 cleaning, which should be the gold standard? What does that chemical reduction look like through that process? And I think second tier is going to be some of our solar research that's going to take place through ULFSRI, some of the things that TEEX is going to do, where we'll be able to quantify if you are exposed to this environment. This is what you potentially could bring home with you or carry around with you in your gear. So we just want to have a better informed community and don't go into one of these new energy settings with blinders on.
The testing that we're asking to be done to thin film material, that's not being done yet. It's not even scheduled. That requires money. And so as much as we could turn to UL to do that testing, we do have to pay for it. And so there's no commitment to that yet. We could turn to TEEX, but it costs money. I would be happy to participate in any lane of travel that would be willing to run down these questions. But right now, we're simply recognizing that we have a gap, but there is no resolution. And this is always a concern, is that when we identify these problems, we have no way. We're not really trying to resolve them. And there's a certain amount of that we can live with. I know that we worry about being in smoke from lithium ion batteries and things like that. And I'm not saying that that's not a valid concern, but the fact is an EV fire still means a rescue out of the gate until you prove that it's not. That means you're going to be in the smoke. That means you're going to be in the thick of it. And so the question will be, how do we respond going forward? Because the rescue is the priority. It's still what we're paid to do, keep humans from being dead. And so I love the idea of the fire service moving away from just standard flash hoods and moving to particulate hoods to try to keep some of those chemicals off of the gap, which really is your neck. That's your PPE ensemble gap. It's your neck. And particulate hoods close that gap. But the reality is that we're going to be in this smoke. So decontamination becomes so important. And I do think that TEEX is really leading the nation in trying to get answers and identify what is the best cleaning medium out there. Because the fact is, we know it's not water-based extractors. We know 30 years ago, yes, that was probably the best we had. But now, with liquid CO2, that is likely our best way of cleaning, of really decontaminating our gear.
And I really hope our audience that listens to this podcast will come away with something. even though we didn't provide any concrete answers, even though after all the testing and research and trial and error that we've had with lithium ion batteries, both, LFP and NMC technology, we still don't have the silver bullet out there that's going to extinguish these fires. We have ways to control and contain and mitigate the hazards, but there's nothing out there yet that you use this, your problem goes away. We know water-based suppression, it's effective for vapor mitigation, but it's more effective for exposure protection. But, we feel compelled as the fire service community to do something. We're not happy to stand by and let something, kind of run its course. But until we get the chemistry, the technology, our problem really isn't going to go away. And like Chris mentioned, there's a lot of technology via chemistry. Chemistry changes that it'll change the landscape of what a battery looks like, in the future, whether it's silica-based technology, whether it's solid state or hydroxide. There's a lot of things that are making progress out there. But we know, even if we stop making lithium ion batteries today, we're going to have 10 to 15 years of legacy hazard out there. So it has to be addressed. Even if the chemistry changed tomorrow, it still has to be addressed. And, really, we hope that you found some value in the solar podcast today. There is some unknown hazards out there, but just be aware. If you see something collecting energy, it's processing that energy, it's storing that energy, and it's getting ready to pass that energy on to the customer. So just be aware of those potential hazards in the course of your job duties.
Well, Gordon, I sure appreciate you having me. I love working with TEACS. The academic footprint for TEACS is massive and ever growing. I love that TEACS is really making energy hazard training for the fire service a priority. And that's been a gap for about 100 years. And so to be able to work with TEACS on this energy hazard training is it's something that I'll always be available for and I'll always want to do. So I sure do appreciate you guys having me.
Yeah, and Captain Green, we can't thank you enough. One of the leaders, if not the leader out there on all things energy, and we appreciate your time, your knowledge that you're able to give back to the response community. It's just invaluable, the education process that we're able to facilitate together. And it's always a pleasure working with you, sir, and we look forward to working again together in the very near future.